Exploring Huygens' Principle, a physics-optics perspective.
Welcome to the Universal Principles podcast. Today we're diving into Huygens' Principle. It sounds complex, but it describes how waves propagate. To help us understand, we have an expert in physics and optics here. Could you give us a bit of context about where this principle fits into your field?
Thanks for having me. What's fascinating about Huygens' principle is that it provides a beautifully intuitive way to understand wave behavior. In essence, it states that every point on a wavefront acts as a source of secondary spherical wavelets. The envelope of all these wavelets then forms the new wavefront. It demonstrates how emergent properties arise from local interactions, with individual components giving rise to a coherent whole.
That's a great explanation. Could you walk us through a concrete example of Huygens' principle in action?
Certainly, think about light passing through a narrow slit. Instead of just projecting a sharp line, the light spreads out. This is diffraction. Huygens' principle explains this perfectly. Each point within the slit acts as a source, emitting wavelets that interfere with each other, creating the diffraction pattern we observe. Another example is modeling wave propagation through complex media. What happens when light hits a rough surface? Each point on the surface becomes a new wavelet source, leading to reflection and scattering.
So these wavelets are like tiny individual emitters working together. This interference must be key. Does this principle apply outside of just light waves like with sound?
Absolutely. Huygens' principle isn't limited to light. It applies to any type of wave, including sound waves. Audio engineers use it all the time when designing concert halls. They need to minimize sound interference and reflections to create the best possible acoustic experience. By carefully considering how sound waves propagate from various surfaces, they can shape the space to optimize sound quality.
That's fascinating. It's amazing how a principle governing something like light can have such practical applications in architecture. Are there any principles similar to Huygens that we see in other fields?
Interestingly, the concept of interference as information encoding, used in holographic data storage, shares a similarity. Just like wavelets interfering to create a new wavefront, different beams of light interfere to encode data within a holographic medium. The interference pattern stores the information, and by shining another light beam, we can retrieve it. It's a different context, but the underlying principle of using interference to create something new remains.
So if someone wants to apply the spirit of Huygens' principle to, say, problem-solving or innovation, what practical advice would you give?
That's a great question. First, break down complex problems into smaller, manageable components. Think of each component as a wavelet. Second, consider all possible interactions and influences. Wavelets interfere, so consider how different elements will influence each other. And third, look for emergent patterns. The new wavefront arises from individual wavelets. Can you see a coherent outcome from these interactions?
Fantastic advice. Break it down, consider the interactions, and look for the patterns. This has been incredibly insightful. Thank you for shedding light, pun intended, on Huygens' principle and its universal applications.
My pleasure. It's always fun to explore these fundamental principles.
And that's all the time we have for today on Universal Principles. Join us next time as we uncover another fascinating principle shaping our world. Until then, keep exploring.